Nice to meet everyone. Yeah. I'm an EM at Okta. I currently lead the delivery automation platform and Kubernetes integrations team. My team broadly deals with a lot of, day-to-day operational work, infrastructure platform work, and so on. So I'm very close to this problem, and I've, sort of been looking for ways to have a adoption pathway and framework that is translatable. So I'll just get into the presentation if we have time at the end. I do have a quick demo prepared, so maybe we can get to it. So one of the major problems in with AI agents right now is with infrastructure in general right now is that we have a lot of complexity in modern infrastructure. I'm sure a lot of us on this call have spent hours trying to debug what a Helm file does, or a particular 500 line like YAML manifest created by knowledge silos over time. What this actually does is it creates these single points of failures across your organization, where you have to rely on the kindness of individuals and sticky notes and so on to bridge this gap. And information becomes stale over time. Things are not updated. Runbooks go out of state. Your configuration is not, has drifted from what's actually running. There are several points of failure in this. So to overcome this complexity chasm, we can leverage like LLMs and agents to move to sort of the next milestone in DevOps. So what does this look like, right? So currently, like traditional DevOps can take a couple of forms. Like you have automation that's tied to scripts, knowledge that's passed on outside of traditional or like standard channels. In you have people talking to each other. You may have like a couple of Slack channels where some conversation is going on. You may have some out of date wikis. um, Documents go stale quickly, and then you discover this when you're in the middle of like a SEP 1 or SEP 2, and suddenly like the documentation you relied on is no longer the correct one. um, Tooling also cannot keep pace with changes in infrastructure. Um, More often than not, you end up using substandard tooling, or you end up using tooling that no longer is suitable for the problem you're trying to solve. It also has the disadvantage of having a steep learning curve for newcomers whenever it is custom tooling and not something that is industry standard. So how can we move forward from this, right? Or how can we actually like uh, integrate LLMs and AI agents like effectively? So we can move to a system where we are able to understand, use agents to leverage system context. So you can connect them to logs, metrics, configs to see what's happening, give you an overall sense of the picture. Once you have that, you can use natural language queries to query your observability stack. You can hook it up to like Slack or a CLI or any other UI. So your context switching is minimal. You have a single pane of glass where you can do all of these requests and get a lot of context immediately in a single place. You can also have agents update docs currently. If something goes wrong, you realize that some process or a wiki or a CLI is out of date. You use agents to go fix that either in the code or in wherever your documentation lives, right? It can also run in a loop so that you have these context-aware agents monitoring different sources of information and updating documents as time goes on. So you don't have the data staleness problem, which is there in traditional DevOps. And I think the fourth way, and this is sort of the crux of it, right? Like you can explain decisions clearly with agentic reasoning. You can summarize failures, suggest fixes, and keep human in the loop for the path forward. So what I would like people to take away from this is that the solution is not more automation. It's understanding and cognition, right? Like you don't want to just add automation for the sake of it. You want to have some way or some agents that are able to more deeply understand the problems that you are facing, and it's almost like having a teammate that is always on. So that's how I would like frame this discussion. And beyond this, like we can talk a little bit about what does what are sort of your North Star um, pillars, right? Like that you should look at when you are trying to integrate like AI agents or AI ops into your workflows. The first one is utility, second one is security, and the third one is knowledge codification. So I'll just go over like what I mean by each of these. So utility is just going to be, does this actually solve a problem? Or is this just a fancy wrapper that someone built because they found it cool? Um, so the point of utility is that you need to reduce cognitive load for your engineers. Some examples of this would be you have documentation generated on demand, you have explanations for Terraform for people who are onboarding for the first time, for Kubernetes, CI/CD pipelines, manifests, and so on. It helps you to have a better understanding of your infrastructure and your documentation and your configuration in a very streamlined manner with very little overhead. And then context-aware search. I touched on this earlier a little bit, but just having natural language queries that can go to like Splunk or Datadog or Prometheus, Grafana, or whatever it is that you use. Um, it vastly reduces the time between you thinking that there's a problem and understanding like what logs are saying or metrics are saying about that problem. So utility is a key piece that we should focus on when we're looking at bringing in like AI agents over here. The second one, and I am a little biased towards this because I work at a security company, is security and security in action. So what this can look like, and these are suggestions, obviously, but this is what we are trying to integrate within our own stack. So you have intelligent IAC scanning. What this means is you have an LLM or an agent scan through your code, your Terraform, to see if things are misconfigured. If you see that you have too permissive policies, if you see unauthorized users or so on, you can basically have static analysis over there and agents fix them in code for you. The second one is, I think, pretty much where a lot of these things are converging is the like incident triage assistance. So you are able to have agents where you correlate alerts and deployments and have like root causes when you interact with a platform such as Slack. So that gives you like incident triage in a singular place. The third part would be something like guided security processes. So when you're setting up a new service, like one of your engineers is setting up a new service, they don't necessarily may not necessarily know about a lot of security best practices. It may not be the thing that they focus on. They may be focused on business logic. So you probably can leverage agents to walk them through things like credential rotation, IAM setup, IAM policies, least privilege, and so on. The true utility of all of these things is in authorization boundaries, however, right? Like you want to define very clear boundaries for where your agents are able to take actions. Like for example, you can have an agent running in your CD system, and when it detects problems with the deployment, you can perhaps allow it to do a low level allow it to do like a rollback if it's in a low level environment, or suggest or generate a run book if it's in a production environment. Um, so authorization boundaries are very relevant in this case, because you can specify service accounts. You can think of agents as service accounts with limited access in a similar manner to what you would give perhaps like a more junior engineer, someone who just joined the team, right? So authorization boundaries will allow you to have more confidence in what your agents are allowed to do. And the third pillar is, just codification of knowledge just beyond checklists, right? You want to have a way to take all of this tribal knowledge that you have, take all of these knowledge silos, break it down, standardize into procedures and processes for things like, deployments, for things like incident management. If you have to respond to like a customer is suddenly like facing issues, like what do you do? So you standardizing all of that, enforcing best practices, and allowing engineers to onboard is another pillar of where you could use like AI agents. um, This can even look like, oh, you have a new engineer, they need to onboard quickly. You have like an agent like set up their local environment, have them connect to like a cluster, and they're good to go in like a matter of minutes instead of days. So this is also a way where you take all of these different knowledge graphs, condense them into a single base that your agents can leverage, and your engineers can then focus on doing the work which they were actually hired for, versus all of this like surrounding setup which is just going to take up a lot of time. Okay, so what does this look like in the sense of like an operating model, um, for any agent, right? So this, I mean, I'm sure like a lot of you might have seen this before, but the general loop that any AI agent should follow is sensing, thinking, and then acting, right? So what does this look like in practice? So sensing is going to be like you give an agent access, read access through API keys to things like Splunk, Datadog, Prometheus, so logging metrics and your deployment platforms or whatever, right? It's able to understand when something is wrong or something is missing, and it will allow you in real time to answer the question of what changed now and why is this breaking, beyond simply having a binary classifier of something's wrong, something's right. So it gives you a more nuanced picture of like why is something breaking now, what changed, and so on. Some key metrics you can use to measure this are your mean time to detection, your sort of surface area of your infrastructure covered, and your data freshness. Like how new is this information and how relevant is it as of this point? The MCP tie-in over here is you can provide it with read-only tools, which has access to Kubernetes clusters, metrics, tracing, deployments, and so on. So a single context layer, which allows your agent to sense what is wrong or needs improvement in your infrastructure. Thinking is the intermediate stage, where this is sort of like the LLM reasoning piece, where you can leverage like best in class models to perform an analysis or diagnosis of what's happening. Risk, you basically do something like risk scoring and generate runbooks for next steps. So this will take you beyond just saying, okay, something is wrong, right? And then you, instead of having to scramble to determine what is wrong, you go from something is wrong, here's why it's wrong, here's an action of how to solve it, and here's the person who can solve it, or here's the person who's supposed to like click the button, right? So the thinking gives you the path forward. And this is sort of the intermediate step where you still have human in the loop, you're not autonomous fully. And this, the way you can track it is, mean time to root cause analysis, what percentage of the actions suggested were actually adopted, reducing false positives, and like I was mentioning earlier, the more nuanced view of why this is breaking now. And with the NCP tie-in, you can allow it to have more tools around this reasoning, which effectively translates to some, RPC endpoints that you're able to provide your agent with, and it will be able to leverage that in this stage of its reasoning. And this is truly, I would say, the end state that we want to get towards, right? Like closed loop automation and learning. Um, this is the end state where you basically want your agents to be able to perform actions on their own with minimal supervision in low risk environments. This basically means that your mean time to resolution becomes much shorter. You don't have to do one-off fixes. Even if you do one-off fixes, they go back into the knowledge base, they go back into improving runbooks, code, documentation, and so on. And the way you can merge it, the way you can like track it is you can check, okay, are agents auto resolving incidents, what percentage of this, what is the reoccurrence rate of the same thing, and like how often is an action being taken that is actually going to be the wrong action, right? Like that will give you a signal of like what it is that you need to improve in your system. um, and MCP tie-in is where you give access to your agent with more, like sort of API tokens that have more of a write scope rather than a read-only scope. And okay, So adoption pathway, right? Like this is similar, it's similar to the previous set of slides where every single organization may be in a different, uh, phase of their learning, right? Like you may all not, some of you may have more mature organizations where you don't really need the read-only tools. Some of you may have less mature organizations where you're just starting out and you just want to explore. So this is sort of a like some guidance around like a maturity ladder, where you start off with being an observer, you move on to being an advisor, and then finally you move on to being an actor. The observer is effectively just going to be read-only agents, like I was mentioning earlier, right? Like the goal here is just build trust and allow your company's culture or your organization's culture to shift towards, okay, we can trust agents because all of the data that we've gotten so far is useful for us, right? So the observer is read-only agents. It is an assistant to your day-to-day work in your engineers. Um, Phase two is like sort of the advisor, where this is where you have the thinking phase, which I was talking about earlier in the operational model. The thinking phase is you have access to a more broader set of tools, like your agents have access to a broader set of tools. But over here, your goal is human in the loop. The agents will only suggest, the engineers decide. This can look at things like static analysis of code, real-time actions in deployments, real-time actions in incident management, when you have requests, floods, and so on, right? Like, and then you can decide like where do you want this to be integrated in something like Slack, Teams, or whatever it is, where your engineers are most likely to have the least amount of friction to perform an action. And the focus here is adhering to security practices and breaking down knowledge silos, right? Okay. And the final phase is basically the actor. This goes back to the act phase. Your actor, and if you are in the stage of your maturity ladder, then you're already like much further ahead, because at this point you can have agents run autonomously, perform low impact actions, or SOPs, right? Like you can have SOPs be performed by agentic models, where you have rollbacks. If you see a spike in errors after a deployment, you can have scale outs if you see a spike in requests from a particular endpoint. So these kinds of things you can have um, autonomously based on your context aware agent. But this is only after your organization trusts and authorizes your agents to sort of do this work. um, okay. The obvious thing I think we should move on to talk about is sort of guardrails and failure modes here. Like um, some common failure modes which I have encountered are, like hallucination risk. How can you actually trust what an agent says? How can you actually trust what a model says? Like, what is your confidence interval, right? So, having building like prompts in a way that allows agents to tell you how confident they are in your response is a good way to do this. Uh, but you can also start off by just having read-only agents early on, trialing them over like some amount of time, and then moving on to the next one. RBAC and authorization, which I was talking about earlier, this will also help you build confidence in it and guard against like catastrophic failures. And for the most part, I see a lot of organizations just sort of moving towards human in the loop. Um, I think this is sort of going to be a most common pattern for most actions that touch critical workloads, right? Like, I don't think we are like most large companies would be at a stage where they would just let agents run in production with minimal supervision. So I feel like the human approval part is going to be there around like for a long time, but I could be wrong. Um, and then, finally, why even do all of this? What is the point, right? Um, this goes back to like earlier, like when I was talking about utility. The actual utility that we get out of these agents has to be things like faster onboarding, a better understanding of your systems, reducing the time where you can basically have an engineer go from like a new person on the team to like an actual contributor. um, MTTR reduction, this is important for any organization that's maintaining like 4 5 nines of reliability. Time to respond to an incident is a key metric that most companies would try to automate to a larger extent. The more actions are manual, the lower the score is going to be. And then you have fewer tribal knowledge bottlenecks, where this is sort of breaking down the knowledge silos. And the last one is you free your engineers from toil to basically allow them to have a better understanding of the business logic. They don't need to do these repetitive tasks that are not core to their function. So that's the business case for AI agents, and this is where a lot of conversation will converge ultimately. Um, a little bit about local versus cloud LLMs. I would suggest that you start experimenting with local models, but with the caveat that local models can have a lot of security risks in them. So if you're running a local model, you should run them in sandboxes, non-root, pin the shards that you're using to a private registry, um, and basically have guardrails in this place against supply chain attacks. If you're using a cloud model, I would suggest running it in your own private VPC. Focus on your data residency, so that you're able to like make sure that whatever it is that you're sending to one of these cloud models is safe and within compliance, right? So that's how I would approach local versus cloud LLMs. Start off local, experiment, build a POC, then move to cloud models when you're ready to like productionize it. That's the approach that we have been following for the most part. And this is sort of the marketing slide, but it's not really about like your next teammate is not going to be um like they're going to be an agent, but it's not going to like replace engineers. So the goal is mostly to have um augmented augmented engineering, and the way to do that is to have agents that are read only, and then you move up the maturity ladder. So I think that's it for my presentation. I'm happy to take some questions now if we have any in the chat.
Thank you for the great presentation, Kishan. And yes, we do have quite a few questions coming.
Oh, okay. Yeah.
So the first one is, what tools have you used to build ops agents, and which ones would you recommend?
Yeah. So for the most part, like what I've used is we're using AWS Bedrock. So we use AWS Bedrock, and effectively you get a suite of models that you're able to use. Locally, we run POCs using like Golang or Python. Just have a simple POC that's able to reach out to AWS Bedrock, do the prompt injection. And for RAG, we've been using Kendra. So we use like Kendra indexes to allow our whatever the clients to have a up-to-date knowledge base. So some combination of Kendra, AWS Bedrock is what we've been using. In terms of models, I really like Claude. For the most part, I know like things can differ, but I use Claude for like a lot of my day-to-day work.
Thank you. The next question is, how do you ensure support documentation remains up to date given the many possible approaches? What strategies do you personally find most effective for maintaining accuracy and relevance?
Yeah, so I would say that you should start with a sort of commonly agreed pattern for doing things. Like, what a particular deployment needs to look like. The documentation needs to look a certain way. There won't be like too much divergence on opinion on what is the success outcome of a deployment, for example. So any runbook or any runbook or support documentation that is tied to a predictable process. You should have your read-only agents monitor deployment metrics and ingest the documentation to verify that this is still giving you the outcome that you expect. If you see a higher error rate, or if you see that a step is missing and it caused a higher error rate in your deployment or in your rollout or whatever, at that point you have two options. If you are relying on something like a RAG database like Kendra, then you need to make that change so that the documentation is available in the RAG database. And if not, then you can have a agentic model where you indicate to the agent that this step is wrong in the deployment, this is what caused this issue, and you have it, just work in the background to update the documentation. But for the most part, it really depends on what processes you're trying to update, I would say like SOPs are the easiest to maintain over time.
Thank you. The next question is a two-part. So the first part is, can you share your thought process or guiding principles when designing agent systems for this use case?
Okay. Okay, so the thought process is simple. I think the phase that we are in is sort of trust building, right? So building trust and having high accuracy is what I am after. Whenever I have an agent perform an action in my infrastructure, what this looks like in practice is I give it authorization to read only authorization to logs, metrics, and deployment data. And then you use that to have read-only actions that generate a state of the world, like what is going on in my cluster, what pods are not working. We then track that against like false positives, and as that confidence increases, we move on to the next stage where we actually have engineers like follow runbooks that are generated on the basis of this read-only documentation.
And the second part of the question is, how do you approach making these systems accessible and straightforward for other teams to onboard and adopt?
Yeah, I would say your access model can be managed through IAM policies. The simplest way that you can do it is you have an entry point for your application where you check their roles, right? Like, so if you're using an IDP, whether it's Okta or something else, you are associated with a certain group. You can check group membership and allow certain teams or developers to onboard early on and increase group membership as needed. So the way we do it is, we have like a simple UI and an OIDC application that checks a particular user's groups against when they're authing in, and then we either allow or disallow access. To request access, you can have a similar process. You can build out a workflow where someone requests access to a particular group, it gets approved, and then that's how they move on, right? There are pipelines you can build around this, but for the most part, an example of this would be AWS Identity Center. It has a way to group people into certain levels of access and authorization, and you can have your agentic application live within that AWS account. I'm sure GCP has something similar, but my scope is is AWS, so that's right what I'm talking about right now.
Next question. Are there open sourced agents which we can model our own agents on, like analyzing Splunks?
Yeah, I would recommend using something called K8's GPT. They have something pretty cool where they allow you to plug into like Splunk, Grafana, PagerDuty, and so on. The other one I can recommend is looking at something like Rootly. Rootly is like a AI infra lab. They have a lot of like open source work around this, where you can plug and play like and swap out like models. Those are the two that come to mind. For me, for the most part, like I have been mostly using, when I'm running things locally, I use Olama or Mistral. But if I'm using something like through AWS Bedrock, I will use Claude for most of my the day-to-day work.
And we have one last question. Are agents installed as a master-slave approach, where agents reside in master node have access to all slaves, where it can take an action based on reasoning? Are there any chances where master agents can go rogue?
Yeah, so I think the way to approach this would be through like the MCP protocol. It really depends on what your agents have access to. So you would define tools that pretty much specify what an agent can do. I don't think I've come across a master slave configuration. For the most part, it is your agent is effectively just at the end of the day, it's like a Python or Golang client or something lightweight like that. So it is going to be a container running somewhere. That container does not necessarily need to have it can probably spin up sub containers if it needs to, and that will create that relationship. But that depends on what tools you give access to it. Can it go rogue? The possibility exists, because if you have too broad of an authorization scope for your agent, or you allow your agent to make changes to authorization, then you cannot predict what it is, what the blast radius would be like in that case. Which is why one of the things I spoke about, throughout the talk, was that follow the principle of least privilege, only increase access and authorization after some level of like trial and error and trust has been built. You can't rule that out. That's why your adoption should be very deliberate and sort of data driven before you do this.